All right, this is similar to what you're going to see in problem number 5 from section 1.1, and it just says solve the system. So this one's a little bit tougher than number 1 because obviously it has 3 variables and 3 equations, but we'll approach it the same way. Let's form the augmented matrix first. And notice, by the way, in the first equation, I'm missing an x1 term, so the coefficient there is understood to be 0. And same thing with the coefficient of x2 there, it's a 0. This one's definitely going to be more messy. All right. But remember, you always work on these things one column at a time, and this should be 1, 0, 0 if we put it in reduced echelon form. And there is echelon form, but reduced echelon form is always, I think, the nicest. So the first thing I want to do is make this a 0, this 4. So I'm going to multiply the first row by -4 and add it to the second row. So I'm not going to change the first row at all. That times -4 plus 4 is 0. That times -4 plus 2 is 2. This times -4 is 24. And I'm going to add that to -11, so that looks like 13. And let me see, I need a calculator for some of this. 23 times -4 is -92, and I'm going to add that to 59. That'll be -33. Okay, and we'll just recopy the last row. All right, so it looks like that first column is finished. Now I want to make this guy a 0, 1, 0 if I can. So it looks like I probably want to take the first, or I should say the second row, and divide by 2. And there are other ways to do this. I'm just doing it my favorite way. But I'll divide the second row by 2. And we'll just leave the third row the way it is for right now. All right. So now the only thing I need to do is change this into a 0. So I'm going to say -R2 plus R3. I'm going to multiply the second row by -1 and add it to the third row. So I'm going to leave the first row exactly the way it is, and the second row exactly the way it is. Okay. But I'm going to multiply the second one by -1 and add it to the third one. So that'd be a 0, that'd be a 0. I'm going to use a calculator for the next calculation. -13 over 2 plus 4. And that's supposed to be -5/2. Okay. And now 33/2 minus 9. That ends up being 15/2. Okay. So now let's work on this third column. I guess we need to switch pages. So I want to start by making this thing a 1. So I'm going to divide the whole third row by -5/2. So I have to be a little bit careful. Let me see. 15/2 divided by -5/2. So remember, when you divide by a fraction, you multiply by the reciprocal. That'll cancel the 2's out. So it looks like -3. So that turns into something nice. All right. And I guess I'll go ahead and finish putting this thing in reduced echelon form. So I just have to make this a 0 and make this a 0. Okay, this one's a little more complicated than the first one we did. But certainly the last row is okay the way it is, so we'll just recopy it. But it looks to me like I need to take the third row multiplied by -13/2 and add it to this to make that a 0. So that's not going to change the first two elements in the second row, but it'll change that to a 0. Now here's the hard part. I got to multiply this by negative 13 halves and add it to that. I'm going to use a calculator. But I get a nice number. It's just a 3. Okay. And what's the last thing we need to do? I need to change this to a 0. So I'm going to say 6 times the third row plus the first row. That'll change that to a 0. But it won't change the first two elements. Change that to a 0. But now I've got to say 6 times this plus that. So it looks like that'd be negative 18 plus 23, which is 5. So it sure looks like the solution is 5, 3, negative 3. And remember, this is x1, x2, x3. So that's probably the answer, but we can always double check by plugging it into the original system. So that's what I'm going to do. Let's see. Just to make sure, since there are a lot of steps there. But 5 minus 18, I'm sorry, 5 plus 18 is 23. So it looks like it checks out in the first equation. And if I plug it into the second equation, it looks like 20 plus 6. That's 26 plus 33. That is 59. So I just checked the first two equations, but that's got to be the right answer. So that's just another example of Gauss-Jordan elimination and putting your system or your matrix in reduced echelon form. It always makes the solution really nice.